Hi, welcome back, and it's Mike Visser again talking about lightning protection. Now, the question that very often comes up is, how often is maintenance required on lightning protection systems? Well, the Code of Practice actually defines that the planned maintenance requirements of your system is dependent on the risk profile that you have. Now, as we've mentioned in other videos, IEC 62305 in essence gives us the 4 levels of lightning protection, where level 4 would be the least stringent and level 1 would be the most stringent. And obviously, if you've got that massively high risk, you're going to need to do maintenance more often than perhaps if you have a lower risk. So let's take an example for a domestic environment. It's not a very active environment where you've got vehicles moving about that could cause damage to the system. Generally, in that kind of low-risk environment, you don't have a lot of things going on that would put the lightning protection system at risk. And as a consequence of that, you actually don't need to do the maintenance as often as you would in, say, a Class 1 system. Class 1 system, say maybe a manufacturing plant or a petrochemical type plant where you do have forklifts moving about, you do have heavy vehicles moving about, trucks coming and going. In that kind of environment, obviously, you're going to be wanting to do your inspections more often. And then, of course, if we go to the worst case scenario, something like an explosives magazine. Very often we are testing our mining clients' explosives magazines, and what we're finding is that minor damage does occur. For example, where they're running the cocoa pans and they're loading the explosives into the cocoa pans before they're moving that off to the shaft, we're finding that, for example, the rail bonding occasionally takes damage. The cocoa pan could be dragging something, it could get snagged in the rail, it picks up the bonding conductor, and that causes a problem. So the planned maintenance, how often is it required? That's very much risk dependent. If we're looking at the planned maintenance, well, lightning protection, of course, has 5 major components. Of course, we've got the air termination system. That is the part that is designed to capture an incoming stroke to a controlled point. From there, we've now caught this massive amount of energy. We've got to get it to ground level. That's the down conductor's job. And once we get it down to ground level, we now have to shunt it into the ground safely, and that is the earth termination system. Now, to prevent any potentials coming and going anywhere on the site, we install equipotential bonding. That ensures, for example, like the explosives magazine, the cocoa pan rails are bonded to the structure of the magazine, so that in the event that the lightning takes a strike, the entire system rises in potential, the rails, the cocoa pans, the actual system, the power system comes down, you get all the restrikes, and no surges, no potentials develop anywhere. A point to mention here is then the last component of our lightning protection hardware, which is the surge protection. And of course, the surge protection is there to ensure that as that structure and all the equipment is rising in potential, the substation that's feeding all that electricity 50 meters away, 100 meters away, whatever it is, but it takes a short period for the surge voltage to get to the transformer and back. That surge protector is going to clamp that down and then prevent all the electronic equipment and electrical equipment taking a big belt. And of course, surge protection is ultimately there to protect the equipment that is connected to the electrical system. And it is a vital component. So when we're talking about planned maintenance, what we would recommend is surge protection should be examined really at the beginning of every lightning season, whether or not it's part of the external protection evaluation or not. And the 6265 and the Code of Practice for Surge Protection insists that the device that you install in your distribution board to take care of that momentary blip in energy between the transformer and the physical structure is maintained at a survival voltage for all the equipment in the system. So that is a very easy maintenance component, because you really just need to look. Is the little tag on the surge protector green, or is the tag on the surge protector red? If it's green, you're good to go. If it's red, the device has taken a catastrophic surge. So equipotential bonding, that was the 4th component we're talking about. If we're looking at the planned maintenance of your equipotential bonding, really, what do we want to look at? We want to make sure that the conductors are still there. For example, we've got that tail from the one rail to the other rail, and then from the rail to the structural lightning protection or to the distribution board earthing. But once again, you want to examine that conductor, and then of course you want to look at the termination of that conductor to make sure that on the DB earth bar, that is still strong, and at the rails, both connections on the rails are still strong. We haven't vibrated them loose or anything. So that once again is a question of bonding. Obviously if we use a nylock nut on those bolts, there's a much lower likelihood of them vibrating loose. But once again, we're talking about equipotential bonding. The tables upon which they're packing out the explosives between the vehicle that drives in from the magazine, puts it onto the transfer shed table, that table obviously will need to be earthed as well. So when we want to see what the earthing is like on the table, we need to basically, once again, inspect the terminations, inspect the conductor, and then, of course, to make sure we do a resistance test. In other words, that's a continuity test from the distribution board, which the earth bar in the intake distribution board is our point of zero potential for the infrastructure. So we would then clamp the one side of the continuity lead on there, get the other side on the table. Yep, we've got a good low resistance. Check the one rail, check the other rail, check the structure, check any other loose equipment that you might have on the site, whether it's tables, anything conductive that comes in contact with those critical loads. Obviously, you're going to be inspecting and testing. In a domestic, in a less stringent environment, you could get away with inspections, perhaps testing inspections every 2 years and just a visual inspection every 1 year. So very much you factor in the risk, the level of lightning protection, and the period during which the planned maintenance will be required, and that then will dictate how often you're going to do it and which part of the maintenance program you're going to do as well. The Code of Practice gives us the visual inspection in between the full test, full inspection. Of important note, to conclude, if you are aware that your system has been hit by lightning, you have to, in essence, do a complete compliance check. In other words, you've got to get up on the roof, inspect every connection point on that air termination system, inspect every connection point on the down conductor system, check all the fixings, that all the conductors are still where they are. Because when you get these massive electromagnetic fields developing during the event, conductors move about depending on what's in the area. So yes, if you know you've been hit by a lightning event, a flash of lightning, then yes, you're going to do a full inspection. You're going to do complete resistance testing of every electrode that makes up the earth termination system. You're going to do a full inspection and test of all your equipotential bonding, surge protection, air termination, down conductors. It is a complete inspection because things vaporize during lightning strikes. Things get damaged during lightning events. And that is why the Code of Practice is quite explicit. If you know you've been hit by a flash, you do a complete commissioning test one more time. I hope you found this informative and helpful, and if you need to find out more about this, you can please contact us at Power Quality Company. Thank you very much.